Hello. Now we will be reviewing Chapter 5, which goes into the design of surveys and experiments. The first thing we need to do is know the difference between observational study and an experiment. Uh, in an observational study, we observe individuals and measure variables of interest that but do not attempt to influence the responses. And this is the big issue. Where in an experiment, we deliberately try to put some treatment or we do something to somebody and in order to observe their responses. When we're sampling, we're trying to study a part of a group to gain information about the whole group. So we're taking, getting sample means and sample standard deviations, and we're trying to infer what the whole population is like. Where a census is when we try to contact every individual in an entire population and see how they feel about a particular issue. A study is biased if it systematically favors certain outcomes. There's many types of bias. Under coverage, this is when, say, if Asians make up 10% of our population in a particular area and only 5% of uh, the people in your study are Asians, that could be under coverage. You're not getting everybody in a particular, it's not representative of the whole population. Non-response is if you send out a survey and you only get back 30% of your surveys, you have no idea what the other 70% uh, how they feel about the issue. Response bias, you can get a response bias if the interviewer does something that will makes the person not want to be truthful or give the correct response. Maybe an interviewer is interviewing about political affiliation and they have a Democratic or button on, that might change how the person responds to the questions. Also, the wording of questions. Sometimes uh, the questions are worded so poorly that you don't know exactly how to answer um, to be honest. So the wording can influence a particular answer. A voluntary response is like a mail-in survey or a TV show that people can respond if they want to and or not respond. This way, only the most passionate about a particular issue will get their voices heard. Size bias. I've this is a pretty rare thing that I've seen, but if somebody takes Alaska and gives them more, that's a terrible drawing of Alaska, gives them more votes than say Massachusetts, because Alaska is much bigger, and I should make it bigger than our little Massachusetts. So if you give a place more credit based on their size, that would be size bias. Now, selection bias is if the people you select aren't representative of the entire population. All right, now as you select people, there's these three main ways of selecting people. There's a simple random sample where you name or you number every person in your population, you give them a number, and then you randomly choose with a random digit table, calculator, computer, some way you randomly choose, say, 10 people from that population. So you randomly choose 10 numbers, and then you match those 10 numbers up with the people, and those are the people used in your study. A cluster sample divides an entire population, let's say this area on the map. They divide it into clusters, and then they number each of those clusters. Now, in this particular one, you'd randomly, say you randomly choose two numbers, and let's say you get 3 and 7, and you go to those two areas and survey everybody in those two clusters. Now, a stratified is if you cut people in, put people into groups called strata, and you do that in the beginning. So there's 1, 2, 3, 4, say groups. Maybe it's age, maybe it's grade level, and then within each of these, you do an SRS. And then you compare the results. This would be a stratified sample. Keep in mind in stratified samples, you're doing multiple, struggling with spelling, multiple SRSs, where in cluster sample, there's one SRS. Now, this last one, systemic, it's picking the every fifth person. So you randomly choose one person in the population, and then you choose every fifth person after that. Now, random digits, sometimes we use random digits, and if there's a random digit table, it would look like this. And you can't generate random digits. Usually there's some sort of things that makes it not random. But random digits in the long run will have a equal distribution of each of the values, or pretty similar distribution. Uh, when we're doing these, what you do is, say if we're picking between 1 and 91 items, and you want to randomly choose 4 of them, our first one would be 78, our second one would be 23, then 77, and then 82. If by chance I had uh, a less amount, say if I was going between 1 and 65, what I would do is scratch out anything that is bigger than that, and then I would keep going. So 23 and 56 would be my two samples that I would take. Now, experimental units, subjects, and treatments. The individuals on which the experiment is done on are called experimental units. When the units are human beings, they're called subjects. The specific experimental condition applied to those units is the treatment. So if you're doing, say, plants, this would be an experimental unit. But if now you're doing your experiment on people, that's when they become subjects. And that thing that you're doing to them is the treatment. The explanatory variable in experiments are called factors. Experiments can have many factors, and each levels are how many values for each factor. So you could have, say, light is your experimental variable in growing plants. Your light could have many different, you could have, uh, 12 hours of light, 13 hours of light, 14 hours light, and then you could also have another level of um, how much fertilizer. So you could have fertilizer being, and then no fertilizer, and then you'll have many different values in there. Control is the first basic principle in statistical design. You want to compare several treatments in the same environment, and that's what a control is. Now there's a control group. That's the people that don't get the treatment. So you're putting them in an environment that is the same as the other people, they just don't get the thing that you're doing. Now the three principles to experimental design is control. You want to make sure that all the variables are the same except for the one variable that you want to measure. You want to be able to replicate that, so you do it on many uh, experimental units or subjects, uh, so that so that we know that it's just not something that happens in one or two people. It happens in many, many people. And you want to be able to replicate the study many, many times and get the same results. You want to randomize also. A randomize is to use impersonal chance to assign experimental units to treatments. The goal of randomization is to make sure you have groups that are pretty equal. Now to do a completely, totally randomized design, we actually talk about it in a couple slides, but you take all your subjects and then you randomize them from here into your two groups. Say this is the treatment, and down here is the control, and then you want to compare to see what happened. A placebo effect is a response to dummy treatment, giving somebody a sugar pill or pretending to do a surgery and not actually fixing um, the issue. The goal in an experiment is to get a result that is unlikely to happen by chance. And chapters 10 through 15, I'll talk about statistical significance in more detail than chapter 5. But basically, if you know your 10 through 15, if your p-value is then lower than your alpha level, then we say that the data is statistically significant. Now, assigning to groups, I would give, if there's 150 people in a study, give them all a number and randomly choose 25 distinct numbers, and all of those numbers are different, and those people would go into group 1. Then I would take 25 new numbers, either from random number table or a calculator, and uh, all of those numbers have to be different than the first group, and those people would be in group 2. And you keep doing 25 distinct numbers until the rest of the people are just in the last group. Another type of design is called the block design, and that's you use a block design if you know that there's something about the study that um, or something about the people or experimental units that you know or you have a hunch will lead to different results. Uh, so that there's some systematic, it's expected to systematically affect the response. Um, for instance, men and women might respond differently to cancer treatments. So you start a block design out by separating it into men and women, and then you randomly assign them to the 3 groups. They get the therapies, then you compare their survival rates. Now, a completely randomized design is just having all the subjects in one group and then randomly assigning to them to the 3 different groups where they get the therapies and compare survival. The downside about the completely randomized design is something might work well for women and not for men, or vice versa, and you might not be able to see significant results because of because they're combined with people who didn't get results from it. Now, matched pairs, a common form of blocking for uh, is having matched pairs. There's a couple different types. Sometimes the matched pairs of 2 subjects into groups that are very similar. Pick 2 people with very similar demographics, and one person gets the control, the other person gets the treatment. Another way you can do it is each subject receives both the treatments and in random order. So they'll get the control first and then the treatment, and other people will get the treatment first and then the control. In a double-blind experiment, neither the subject nor the person carrying out the experiment knows uh, uh, who's getting the treatment and who's getting the control. And that is the end of chapter 5.